use graph absolute value inequalities, and one of 4 cases is going to happen when you do these. Once you get the absolute value expression isolated all by itself with an inequality symbol, you're either going to get absolute value expression greater than a positive, absolute value less than a positive. Those are the 2 that actually matter. Those are the 2 that can be graphed. I should say this one can be graphed also. This one's the empty set, but they're going to have graphs that aren't the entire number line. All right, so you're going to get greater than p, less than negative p, so it'll be like an open circle at 3 going this way, open circle at negative 3 going that way, or if there's an equals 2 closed circles and going whichever direction. If it's less than a positive number, it's going to be from the negative to the positive number shaded in between. Absolute value greater than a negative number is always true because absolute value is positive, right?
Yeah.
Positive greater than negative can never be false. No matter what x equals, the result's going to be positive and bigger than negative. And same theory here, if it's less than a negative number, it's never true because, again, this is always positive, and positive will not be less than negative. So there's no value for x you can pick to make that one true. So basically what you want to do first is get the absolute value expression by itself, bless you, and then compare it to these 4 structures, whichever one it is, case 1, 2, 3, or 4, identify that case, translate it correctly to an expression not containing absolute value bars, x's only, or it's always true or it's never true. Alright, so let's give it a shot with number 1. Graph absolute value of x is greater than 2. So this one's already where it needs to be, right? Absolute value expression all by itself, inequality symbol number. It's greater than a positive number, which is case 1. Case 1 tells me that if I have absolute value greater than a positive number, I write either x is greater than that number or x is less than negative that number. Here's why. Less than negative 2 would be going this way, right? So pick a number less than negative 2, for example, negative 5. What do the absolute value bars do to that number?
Switch.
Make it positive, right? Positive 5 greater than 2. So you take these numbers that are less than negative 2 and they're all increasing in size negatively, but then the absolute value bars change to a positive number. So that's why it creates this one. And that one's pretty obvious because it's, 5 is greater than 2, so absolute value 5 is greater than 2. So that's pretty straightforward, the first one, but the second one, again, x is less than the negative version of the same number. So what I want to do is graph both of these. It says or, and what we learned about disjunctions is when the word says or, we graph both inequalities on the same number line. So x is greater than 2 would be an open circle at 2, open because it does not equal 2. And then greater than goes to the right, so we're going to shade this direction. And we make the arrow nice and bold to show that it continues on forever in that manner to infinity. X is less than negative 2, open circle negative 2, because again it does not say equals, and less than goes to the left, so we go this direction. And we make that arrow nice and bold to show that it goes on forever to infinity. And that is the answer to this problem. When you get case 1, that's what the graphs are going to look like every time. Open or closed circles going opposite directions. Every single time you should expect that type of graph for a case 1 absolute value inequality.